Hello, welcome to this lesson, which is how do you form ionic equations. I'm really quickly in this video going to show you kind of the context of ionic equations, so what topics you see them come up in, and then we're going to go through a couple of examples together. First of all then, where you see ionic equations come up, so they come up in displacement and they come up in the salts topic, so where you look at different reactions that create salts. Let's first of all look at displacement. So I've written here a quick example that we're going to go through together. So displacement is where you look at or two metals, a metal on its own and like a metal in a salt. So here I've got magnesium, the metal on its own, and I've got copper sulfate, a metal salt. You look at the reactivity of those two metals and you decide whether one displaces the other. Now in this example we've got magnesium. Magnesium is a very quite a reactive metal. Copper is far lower down in the reactivity series. So here what would we would actually see is we would see that the magnesium would displace the copper. So we'd end up with magnesium plus, let me remove that. We would end up with magnesium sulfate plus copper. Okay, the magnesium would displace the copper from the sulfate, and copper would end up on its own. So that's a displacement reaction. That can be turned, that is a word equation, that can then be turned into a balanced symbol equation and then an ionic equation. Another example of where you will see ionic equations is salt reactions. Okay, so in this example, we've got zinc plus sulfuric acid. When we add a metal to an acid, we always get a salt, and the salt here would be zinc sulfate, and the gas produced would be hydrogen. Okay, so these are the two reactions that you could, or two of the, not the only reactions, but they are two of the reactions that you can then create ionic equations from. So on my next slide, I've got a couple of examples to go through. First ones we're going to look at is a displacement, the displacement that we actually just looked at, funnily enough. So we've got magnesium plus copper sulfate gives you magnesium sulfate plus copper. So what I'll do, because you could have started with a word equation and then you'll have to do a balanced symbol and then you'll have to do an ionic equation. Sometimes they will give you the balanced symbol and you just do the ionic, but let's just say we were starting from the top. So if I was going to answer this question, I first of all need to write out the balanced symbol equation. Okay, so we've got magnesium is Mg. Before we start, actually, please can you have your, if you're doing these examples live with me, maybe on a sheet of paper or in your book or something, have your common ion sheet in front of you. If I've taught you over the years, I've definitely given you this sheet. If not, it's available on all of my other resource platforms, so please go and find it. Drop me an email if you can't. So going back to our word equation here that we're turning into a balanced symbol equation, we've got magnesium Mg. Now copper sulfate is made of two ions, and I've done a video already on how you would find out what the formula is for that, and it's using the drop and swap method is one way. So I'm not going to recap the drop and swap method now, but if you're unsure on how you would do the formula for copper sulfate, please watch the drop and swap method video. So we have got CuSO4 for copper sulfate, magnesium sulfate MgSO4 plus Cu, copper. Okay, now you would have to check that is balanced. I already know that this equation is balanced. We've got the same elements and the same number of atoms of those elements on either side of the equation. So that is your balanced symbol equation. We now want to turn that into an ionic equation. So I'll do this in a different colour. Now, an ionic equation is where you are looking at just the ions involved in that reaction, and not only just the ones that are involved, but the ones that have undergone a change. And that change, later on when we talk about half equations, those changes, we will look at ions and whether they've been oxidised or reduced. Okay, but for this video, for ionic equations, it's one of the easier equations to do. You literally just need to split up the equation that we've written here in red into the ions that are involved. Okay, so two things before we start. Not everything here exists as an ion. Okay, so for example, Mg as a metal, so just in its elemental form, does not exist as an ion. It's a neutral atom. Okay. However, when you get to the salts like copper sulfate and magnesium sulfate, they do exist as ions, and this is why you need your common ion sheet. Now, copper sulfate exists as Cu2 plus and SO4 2 minus. Okay, now copper can exist as different types of ions. In this example, we're only concerned with it being a copper 2 plus ion, but this is what you need to do, is you essentially need to split up all of your different compounds here into their ions, and we're working with ionic compounds. So again, under the structure and bonding topic on all GCSE specs, you look at ionic compounds, so compounds that are made up of metals and non-metals, and they're the ones that are involved in ionic equations. Okay, now we just put a little plus here. We then end up with Mg, and now we are looking at magnesium being an ion because it's bonded with it's bonded with a sulfate, let's just say. Okay, and then in the sulfate we have SO4 2 minus, and now copper is on its own and it is not existing as an ion there. Okay, that's the first step for your half equation. Now we have to remove something called spectator ions. These are ions that have not changed on either side of the equation. Now if you look at magnesium, actually I'll just change the colour. If you look at magnesium here and you look at magnesium here, you can see that the atom has changed into an ion. So they are not spectator ions because it has undergone a change. Look at copper. Copper is 2 plus here and it's neutral atom here. So it has undergone some kind of change. And like I said, we explain that change when we look at half equations in a separate video. Now look at our sulfate ion. SO4 2 minus, SO4 2 minus. That ion has not changed on either side of the equation, so we call it a spectator ion. It literally, and this is how I say to my students to remember it, it is a spectator in this reaction. It is just sitting back and watching what is going on. It's not involved in any kind of change. So we actually remove spectator ions. Okay, so now I'm going to write out the full complete ionic equation for that reaction between magnesium and copper sulfate. And that is it. It is that simple, okay? So there, in that lighter blue colour, is the ionic equation between magnesium and copper sulfate. And that is all you need to put as your answer. Let's now look at the equation between zinc plus nitric acid gives you zinc nitrate plus hydrogen. So this is a salt reaction. We're adding a metal and an acid to give us a salt plus hydrogen, like I quickly explained on the previous slide. So again, we will go through and we will do in red the balanced symbol equation to start off with. So we will have Zm plus nitric acid, which is HNO3, which is going to give us zinc nitrate plus hydrogen. Okay, so again, if you're unsure there with how I did nitric acid or zinc nitrate, you need to watch a different video called the drop and swap method. Really, the acid formulae on most GCSE specs, there's 3 or 4 acids that you have to know by heart. So that's why you would have known, or you should have known the nitric acid one there. But like I said, that's on a separate video. So the next thing we'll do, we need to check that it's balanced. The previous one we didn't have to. This one we do have to check that it's balanced. And it's really simple. We put a big 2 here. And that's important later on in the video. And I'll explain then why it's important. So that is a really key thing there, is to always check that your balance, if they've asked you to do a balanced symbol equation and then an ionic, please check that your balanced symbol equation is actually balanced. Okay, again, I've got a separate video on how to balance equations, so please give that a watch if you're unsure there on why that equation there in red is now balanced. So let's get on to doing our ions. So Zn as a metal on its own is not an ion. We've then got, and if for the moment I'm going to ignore that big 2 that I've put in, and I'm just going to write out the ions. Acids are consisting of H plus ions. Nitric acid also has the NO3 minus ion. You've then here got Zn. When it's in a ionic compound, it is 2 plus. We have got our NO3 minus ion. Hydrogen in its elemental form as a diatom, as a gas, is just H2. So that's the first stage of the Ionic equation. Again, we're going to go through in a second here why that is not finished and what we have to remove. Okay, so let's go through. Let's look at zinc here and zinc here. We're now trying to look at if there is any spectator ions. Now, zinc has undergone a change on either side of the arrow there, so it is not a spectator ion. Let's look at H+. It has undergone a change. It's turned from H+ to H2. And finally, we look at the nitrate ion. The nitrate ion, NO3- there, has not changed from one side of the equation to the other. So this is our spectator ions, and they are going to be removed. I'm just now going to write out your full Ionic equation. That would get you marks in the exam. So Zn plus H plus arrow Zn 2 plus H2. Now I'm going to come back to the big 2 that was in our original equation here. Okay, you do have to include that in your final Ionic equation, and all it means is that there is simply a 2 here. Okay, and that is it. That is Ionic equations for you. 2 examples. The top one, I would say, is slightly easier. The bottom one giving you an example of where lots of students can kind of slip up on these, where they don't balance the equation. So a couple of things you can now do. You can go make notes from this video, go and practice some yourselves. Maybe start the video from the beginning, pause it before I start going through these and have a go at them yourselves. Like I said, other videos to watch after this because the videos kind of link into one another. So after this video, maybe watch the half equations video. Before this video, like I said, I would have suggested that you watch maybe the balancing equation video I made, or the videos that I've made about drop and swap. But anyway, please go and practice. That's the best thing that you can do. Good luck. Drop me an email if you have any questions.